So let's look at this video of a bouncing ball. It's in slow motion. So you can see where it was dropped from, and notice that it doesn't seem to come back to where it was dropped from. So what happens to this energy for our bouncing ball? Now, if I'm looking at the system being the ball, and I'm going to put the earth in my system too, because the earth is going to pull on the ball, and that's why it's going to fall down. So I'm going to make it a ball and earth system, so that initially, when the ball was initially up here in its starting position, then the energy was all gravitational energy. All gravitational energy stored in our ball. It was stored in the separation between the earth and the ball. And I know it was rolling a little bit, but let's just say that was very, very, very slow. And so we had zero kinetic energy. It wasn't moving down yet. Now, later, when the ball has bounced back up, but is not moving, so when we saw the ball come down, hit, and then bounce back up, and then hit, and then bounce back up, and hit, and like that. So later, it wasn't as high. So maybe the gravitational energy, was less at that point. Or definitely would be less at that point, because it didn't go to as high a position. And at that point, the kinetic energy, if it stops at that point, the kinetic energy is also zero. So how do I make up for, where did this, I had 3 blocks to begin with, and now I only have 2 blocks of energy. So how do we account for this missing piece right here? Well, there was some energy transferred out of the earth ball system during this interaction with the table. So there's work done by the table, or the force the table applies to the ball, and that work caused a change, and the energy was reduced. So now I wonder if the work done by the surface at each one of these bounce locations, if that work is the same, does this value right here remain the same? Does the energy change by the same amount in every bounce? So that's the question we're going to investigate in your experiment. So is the change in energy, or the work done, the same for every release height? So when the ball bounces from one height up here, if this is our initial height and our final height, is the energy change the same if we release it from a lower height and it bounces to a final height? So that's our question. Is this energy change that occurs at the collision of the surface the same? So to do this, we're going to need some materials. So what you'll need to get a meter stick or a measuring tape. This may be in inches, and if it's in inches, just make sure you convert to meters. A ball, like a tennis ball, lacrosse ball, golf ball, bouncy ball, ping pong ball, whatever you have at home. And a scale. If you have a scale, you can measure the mass of your ball. If you don't have a scale, then just look it up. Most objects have a standard mass. So a tennis ball, lacrosse ball, golf ball, ping pong ball all have a standard or a standard range of mass, and that will be sufficient. Now what you'll need to do is create an experiment to test this question. So you're going to design a lab, and you're going to write down your procedure. This can be a numbered list of your steps taken. You will also need to collect data and put the data in a table. And you will always, whenever we have data, create a graph. And when we have our graph, we also want to make an equation for the line, just like we've done before on other labs. And then you'll have a conclusion. This is where you're going to use the equation of your line and your data to explain whether or not your object, the ball that you chose, does lose or have a change in energy of the same amount no matter what height. So once you have completed that, you will turn it in and the assignment on its learning.